Hello, Energy Tech. Welcome to one of the first of a couple of videos that I want to upload today, all about proofs. So I've had a couple people ask me to do some videos about proofs. I think that's something that people feel a lot of nervousness about. To make this a little less scary, I'll do a couple of these, starting off with a pretty easy one and slowly getting harder and harder as we go. But I'll kind of do it in two parts. I'll do a brainstorming part over here on the left side of my screen, where I'm just kind of marking my diagram and writing out things that I notice that might be useful. And then I'll show you how I actually take those brainstormed details and turn them into a two-column proof on the right-hand side of my screen. Okay, so let's look first at the given information and also at what I need to prove, which I'm underlining here in green. So I see triangle ABC is congruent to triangle DEC, and just to make sure we understand what those are, triangle ABC is right here, triangle DEC is right here. They're the two very obvious triangles. Okay, and so I'm looking to prove that they're congruent, and that's all. And I know that for congruence, right, I have a couple different options. I could use SAS or ASA or SSS or HL, but I'm not going to have to do anything else after I show that the triangles are congruent. I'm not going to have to use CP, or any of that kind of thing. So I'm just making a list here of options for triangle congruence. So I could have SAS, could have ASA, could have HL, which stands for hypotenuse leg, AAS, or SSS. So my brainstorming process is going to try to be to figure out which of those I'm going to use here. So, all right, two pieces of given information. BC is congruent to EC. That's marked there in green. And then in blue, I'll mark the second one. AC is congruent to DC. Well, already I have two pairs of congruent sides between the two triangles. So that's making me think it's either going to be SAS or SSS. I can rule out HL because I have no evidence that this is a right triangle. And AAS and ASA don't seem likely since those only need one side, and I'm given two sides. All right, so as I'm looking around, so if SSS is what I need, I would need a way to show that A, B, and D, E are congruent, but I don't see any evidence for that. There's nothing in the given information that would suggest that A, B, and D, E are congruent, and there's no real theorem I can think of that will be used there too. So let's think about SAS instead. All right, if it were SAS, I would need the angle in between these two pairs of sides to be congruent to the other angle in between those two pairs of sides. And you know what? I actually can think of a reason why angle BCA, right, would be congruent to angle DCE, and it's because they're vertical angles, right? So by the vertical angles theorem, and I'm just going to write vertical angles theorem, kind of an abbreviation here, V angles theorem, right? I know that BCA and DC are congruent. So now I'm starting to see my proof take shape. All right, I'm going to show that these two sides are equal and these two sides are equal, and that's given information. And then I'm going to show that these angles are equal. This pair of angles is equal. So by the SAS triangle congruence theorem, that means that the triangles as a whole are congruent. Once I have that, I'll be done. All right, so let's go over now to the right side of my screen. BC is congruent. And I'm using equal signs rather than congruent signs here just because it's easier to type with the keyboard. When you write this proof yourself, especially since congruent signs are used in the givens here, we should make sure to use those. So that's given. And then AC is congruent to DC, and that's given. Okay, and then the next thing I noticed was that angle BCA is congruent to angle DCE. Angle BCA congruent to angle DCE, and that's because of the vertical angles theorem. Another way of saying that is vertical angles are congruent. And then finally, okay, I have my S, my A, and my other S. So even though I did not write them in the order S, then A, then S on my proof, they do go in the right order in the picture, which is what matters, right? I have an S and an A and an S. So I'm ready to use SAS. Triangle ABC is congruent to triangle DEC by the SAS triangle congruence theorem. I do not write just SAS. I do not write just SAS theorem. I write SAS triangle congruence theorem. And that's it. That's what I was setting out to prove. So I'm done. All right, on to the next one.